Dear students, let's continue and conclude our chapter on genetic parameters. So now we'll expose to you how to estimate genetic correlations in terms of the various methods and its importance and use. Now, there are two methods of estimation of genetic correlation. Firstly, you have the variance and covariance method, and then we have the track diagram method. Starting with the variance and covariance method, it's estimated through this formula that you already have an idea about, where RA is the genetic correlation and covariance A1, A2 represents the genetic value of trait 1 and trait 2 for which the correlation is being searched for, and over the product of the square root of their variances. Now, permit me to explain to you that the genetic variance simply indicates the variance that is due only to the effect of the genes at the strict sense. It doesn't include the effect of the environment, nor the interaction between the genes and the environment, or the interaction between the alleles of the same gene. Now, we have a second method of estimation, that is the track diagram method. How does it work? So initially, let's start by presenting the formula of the additive effect, that is the effect due to the genes, and the environmental effect. So if we assume the formula according to which heritability is equal to additive variance over a phenotype variance as we saw before. Now, if we consider the unit, that is, if we consider that the phenotype is equal to 1, we know that phenotype is equal to genotype plus environment as we saw before, meaning that here with phenotype is equal to 1, this one will become heritability is equal to additive variance over 1. That is, heritability is equal to additive variance. Now, if heritability is equal to additive variance, now the additive effect, that is A, would now be equal to the square root of the additive variance and is equal to the square root of the heritability, and that's how we came out with the formula of the additive variance. Now, knowing that phenotype variance is equal to additive variance plus environmental variance, it simply means that environmental variance is equal to phenotype variance minus additive variance, and that is equal to the square root of 1 minus heritability, since the phenotype variance is equal to 1. Now, once we have this, the next step is all about establishing our tracks. Okay, so we know that the correlation is established between two variables or parameters. If we assume that we are searching for the genetic correlation or the additive correlation between phenotype 1 and phenotype 2, we'll separately represent both phenotype. Phenotype 1 is equal to genetic effect plus environmental effect 1. We represent the formula of each effect. Here we have the formula of genetic effect 1, and here we have the formula of environmental effect 1, or effect of the environment 1. Now we do the same for phenotype 2. Now, since we are estimating the genetic correlation, that is RA. Now, correlation is all about interaction or dependence. So establish the interaction or dependence between these two components. Now, let's start with the environment. What is the correlation between environment 1 and environment 2? It is environmental correlation. So the next elements of our track is going to be the environmental correlation between the two environments. Secondly, what is the dependence or interrelation between genetic effect of phenotype 1 and genetic effect of phenotype 2? This is the genetic correlation, or RA. Now we establish it between the two genetic effects, and it gives us this. Fine. Now we have the last element of our puzzle. What is the relation between phenotype 1 and phenotype 2? It is the phenotype or phenotypic correlation that we establish between the two. And then we have the final element of our diagram. This is the track diagram method. Now, how to read? To read this, we start from this apex at the bottom. So correlation, phenotypic correlation, that is RP, will be equal to the first track plus the second track. So we have phenotype correlation is equal to the first track. What is the first track? We have RE, environmental correlation, times the value of E1 times the value of E2, that is the first track, plus the second track now, genetic correlation times genetic effect A1 times genetic effect A2. Now we have our formula. Now let's not forget that we're looking for the genetic correlation and not the phenotype correlation. Now from this relation, we'll be able to come out with RE, that is equal to this. Dear students, thank you for your kind attention. I hope you played and played and played again, and then keep your few questions for our next chat session. Thank you.